अस्सलाम वालेकुम एवरीवन. क्या हाल है? Walaikum salam. I'm good. How are you? Sir, sometimes during integration the equation needs to be turned into ln. Yeah, we're going to do that. Don't worry. We're going to do that. Don't worry. Walaikum salam. Hello. Nervous for ad maths? Understandable. You should be nervous. But as long as, like I said earlier, as long as you're using that to channel it productively, then you're fine. Yeah, Superman wali t-shirt. Okay, so what do you guys want? Do you guys want me to do the concepts as well, or should we just go straight to past paper questions? Vectors. I've uploaded lots of videos of vectors. Have you not seen it yet? I've uploaded lots and lots of videos on vectors. Concepts. All right, let's go over the concepts as well. ठीक है. All right, no issues. Chalo, we'll go over concepts as well. Poll. No, I don't think a poll is necessary now. How to do the question of the day? The answer to that was 4. It was 2 to the power of x 3, 2 power x 3 upon 2. No, wait. 2x to the power 3 upon 2 equals to 16. मैं कर देता हूँ अभी solve. Okay. So here we are doing integration. Okay. Now we'll go over the theoretical part of integration as well. All right. Walaikum salam. Acha, before I start, you guys know what I'm going to say. What am I going to say? Please like the stream if you haven't done that already. Okay. All right. So remember this. Integration is basically nothing but the reverse process of differentiation. Okay. It's the opposite of differentiation. It's like, division is the opposite of multiplication. Addition is the opposite of subtraction. Integration is the opposite of differentiation. So integration is the reverse process of differentiation. Okay. Now remember, integration is used in two main reasons. Okay, there are two main objectives as to why integration is applied. This is very important. Okay, it's not used for any third thing. It's only used for two things. Number one, it is used to find out the equation of the curve. Okay, that's one reason why we use it, to find out the equation of the curve. Okay, and number two, it's used to find out the area under the curve. Okay, now these are the only two reasons why we use integration. Okay, now you can further extend this principle and apply it to maybe equation of, how velocity is integrated to find out the equation of displacement, or how acceleration is integrated to find out the equation of velocity, but mainly it's used to find out the equation of the curve. And just like that, it's also used to find out the area under the curve. And again, you can apply this and say that it can be used to find out the displacement. Okay, if you equate velocity within limits, then you end up finding displacement. Okay, but that's about kinematics. More about that later, not in today's stream. If I stream kinematics, then we'll learn that as well. But remember, these are the two main reasons why we integrate. Okay, there's no third reason as to why we integrate. There is, but it's not in our syllabus. The third reason why we integrate is to find out the volume. But like I said, that's not part of your syllabus. Not in AS. Not in AdMaths. You'll do that in AS, inshallah. Okay, now, so basically, this is the direction in which we find out the equation of the curve. If you have the equation of the curve, okay, if you have the equation of the curve, which is usually y or f of x, okay, which is usually y or f of x, okay, then here's how this works. इसको center में रखते हैं, ठीक है. You basically differentiate the equation of the curve for what? To find out the gradient function, okay. So if you're going in this direction, what you're doing is you're differentiating it, okay, and when you differentiate it, what do you get? You get dy by dx. Ab dy by dx ka kya objective hai? The objective behind dy by dx is that you can use it to find out the gradient of the curve at any point. You can use it to find out the stationary point, okay, and then you can further differentiate it to find out the nature of the stationary point, okay. But if you have dy by dx and you want to come back to the equation of the curve, what are we going to do? We're going to integrate it, okay. So remember this, integration, as I mentioned, is the reverse process of differentiation. But if you have the equation of the curve and then you wish to find out the area under the curve, okay, then what do? Then you integrate again, okay, but this time you integrate within limits. This time also you integrate, okay, but you do it within limits. All right, now that's pretty much the summary of integration, okay. Now I'm not saying this is it. Obviously there's a lot more. We need to learn how each function is integrated, but this is, you can say, ये जो पूरी statement है ना, ये should be enough to tell us why we need to integrate, okay. Now let's talk about the area under the curve, okay. Let's discuss that in detail. Sir, advanced functions live stream. Let's see. Okay, I'm streaming all the important topics. Okay, today I had to decide between either integration or permutations and combinations. So I went with integration. आवाज कम आ रही है? Really? Is that the case? चलो, I'll increase it if you want. I've increased it slightly. Let me know if it's fine now. Is this a one shot? What do you mean, is this a one shot? What's that supposed to mean? Will hence type questions be covered today? Okay, I'll try and do that. I'll try and do hence type questions as well. Okay, I'll try and do hence type questions as well. Anyway, let's focus on what we're doing, okay? Don't worry about anything else. Let's focus on what we're doing. Okay, area under the curve. आवाज कम आ रही है? Really? Okay, what about now? Yeah, no math today. Today this stream is going to take a while. Okay, so no math today. Yeah, we'll try and finish the entire chapter in one stream. Okay, we'll do all types of questions. So let's talk about the area under the curve. Okay. Now when we're integrating to find the area under the curve, we integrate within limits. Okay. When we are integrating to find area under the curve, we're integrating within limits. And that's also what we call the definite integral. So let's say you have a curve over here, okay, and your job is to find out this area. Again, this is just a random curve with random values, all right? So your job is to find out this area, okay? So this is A and this is B. And this curve has equation y equals to f of x, okay? So you have to find out this area. This is the area under the curve that's bounded by the x-axis, and this is what you have to find. Okay. Now, how do we do this? Well, the way to do this is the following. That we're going to integrate the equation of the curve, Okay, we're going to integrate the equation of the curve within the limits b and a. Okay, so b is what? B is the upper limit. A is what? A is the lower limit. Okay, and what's f of x? F of x is the equation of the curve. Then what you end up getting is the following. You end up getting the area that's bounded by four things. Okay, now what are those four things? The four things are, number one, the curve, obviously. So area that's bounded by the curve. Number two, the x-axis, because your limits are x values. Number three, the line x equals to a, because that's your lower limit. And number four, the line x equals to b, because that's your upper limit. So these two are your limits, and that's how you end up finding out the area that's bounded by the following: the upper limit, lower limit, curve, and the x-axis. Okay? So basically, you can think of it this way: there's these four are your boundaries, and when you integrate the curve within the limits with respect to x, and you do it within the limits x equals to a and x equals to b, so you end up finding out this area. Okay, the area that's inside the red region. Okay, now a couple of things to remember is that what happens if the area is below the x-axis? If the area is below the x-axis, then remember your answer will turn out to be negative. So let's say you have something like this. Okay, so this is what the curve is, and you want to find out this area right here, the area that I'm now highlighting in green. अब ये area निकालने के लिए आप क्या करेंगे? Let's say the equation is g of x. Okay, so in this case, what are you going to do? In this case, what you're going to do is you're going to integrate like you would normally. Okay, Tero, let me just make some room over here. Yeah, so in this case, what you're going to do is you're going to integrate normally. You're going to integrate g of x. Okay, but when you plug in the limits, then what you'll have is your answer will turn out to be negative. So instead, to make it positive, since we're finding out the area, we'll multiply it by minus. Okay, now why do we multiply it by minus? Is when the area is below the x-axis. So when the area is below the x-axis, we multiply it by minus in order to make it positive, because remember, what are we finding out over here? We're finding out the area. Okay, so just remember that if you have the area that's below the x-axis, then you multiply it by positive, then you multiply it by negative in order to make it positive. Okay, then you might come across questions like this also. Then you have questions that are like this. Okay, where you have to find out this area as well as this area. Okay, so let's say, in fact, wait a minute. Let's move it slightly towards the right. Now let's say this is A, this is B, this is C. Now in this case, let's have a look at the wrong way to do it. The wrong way to integrate something like this, and this usually happens in kinematics. Okay, the wrong way to integrate something like this, and let's say this is y equals to f of x. So if you're integrating y equals to f of x within the limits c and a, okay, this is wrong. Instead, what you're going to do is the correct way of finding out the area of the shaded region would be that you'll have to do it in parts. First, you'll integrate f of x within the limits a and b. Then you're going to find out this area. Okay, and then in it, you're going to integrate, and then again, you'll integrate f of x, this time within the limits b and c. And remember to multiply the first area by minus. And the reason why we're multiplying it by minus, so that it turns out to be positive. So this is how you will find out the area of shaded region. Okay, and then you have more cases where the area is in between two curves and stuff like that. So more about that later. We learned that through questions only. But yeah, modulus lagana hai basically. Okay, you can think of it that way as well. This is not this is not math, fellas. This is add maths. Read the title. It says add maths. the first area will not be minus, we'll multiply it by minus to make it positive because it's below the x-axis. Okay, it's not that we're subtracting two areas, okay? We're multiplying it by minus so that it's because it's below the x-axis. Okay? Thank you. Yes, we will do hence find questions today as well. Okay, today's stream is going to be a very long stream because I don't plan on doing a stream on math today, only at maths. Okay, now, so let's go over the type of functions that we're going to be integrating. Okay, so now we have the first case, which is integration of power functions. Okay, now at the same time, we're going to try and recall the differentiation as well. Okay, so here is a recap of differentiation. What does a power function look like? A power function looks like this: ax to the power n. Okay, so that's what we're talking about. We're talking about ax to the power of n. Now, how do you differentiate a power function? D upon dx, ax to the power of n. Now, this is differentiated by multiplying the power with the entire function and taking one away from the power. Okay, this is how you differentiate this. Okay, so this is a recap of differentiation. Okay, now how do you integrate it? As I mentioned earlier, that integration is the reverse process of differentiation. So how exactly are we going to integrate this? So when you're integrating this with respect to x, actually don't worry too much about this dx. Okay, this dx means that whatever change that we're going to do, we're going to do it to the power on x. Okay, so that's think of dx as like that. Okay, so how exactly are we going to integrate this? So here we add 1 to the power and we divide by the new power, and then we add the plus c. Okay, this c is very important. This is basically a constant, and how do we find the constant? For that we need a point through which the curve is passing. Okay, so more about that later. More about that later on. Okay, let's do a few examples of this as well. So let's say that you have to integrate 3x square. So what would that be? 3x square within the with respect to x. So that's going to be 3x to the power of 3 plus c, which means it's equal to x cubed plus c. Let's say you're asked to integrate something like this, 1 upon x to the power of 5. Now, before you can integrate this, remember you first have to make it integration ready. You know how we make it differentiation ready? We also make it integration ready. You have to write it in a way so that it's integratable. And how do you do that? Well, the way to do that would be that you first write this as integral of x to the power minus 5. Now, I haven't integrated it yet. Okay, I'm going to integrate it now. All I've done so far is I've just written it in a way so that I can integrate it easily. So this becomes x to the power of minus 5 plus 1 divided by minus 5 plus 1, which is going to be minus 4, and then plus c. So you can write it like this: minus 1 upon 4 x to the power of 4 plus c, if you want. Okay, I will suggest that you write it like this. You make the power positive, because when you have to find out the value of c, this makes it easier. Sir, bro, you are Clark Kent? Well, maybe I am. Okay, now let's move on. Cursed integration. Okay. Now we move on to the second type. Okay. The second type is integration of composite functions. Okay, and what does a composite function look like? This is what it looks like: ax plus b to the power of n. Remember, ax plus b has to be, ax plus b means that it's a linear function. Okay, now before we learn how to differentiate it, let's recap the before we learn how to integrate it, let's recap the differentiation of it. So how do you differentiate something like this? D upon dx into ax plus b the whole thing to the power of n. Okay, so first you multiply n by the entire function. You take 1 away from the power, so that's going to be n minus 1, and then you multiply it by the differential of the bracket. Okay, and then you write this nicely, na into ax plus b, the whole thing to the power of n minus 1. Okay, now let's integrate this. So how exactly are we going to integrate this? This is going to be integral of, integral to my pehle hi likh chuka hu. So let's write dx over here. So this is going to be ax plus b. Now in differentiation, we reduce the power by 1. Integration, since I mentioned earlier, it's the reverse process of differentiation. So in this, what we're going to do is we're going to add 1 to the power. So you can see that I'm adding 1 to the power. You're going to divide by the new power, which means you're going to divide it by n plus 1. And at the same time, you will also divide it by the differential of the bracket. So that means you will divide it by the differential of ax plus b, which is going to be a. And then don't forget to put the plus c. Okay, so this is like the general form. Then you can simplify and write it nicely and do whatever it is that you have to do. But this is how you integrate a composite function. Okay. Okay, now let's do a few examples. Sir, first question पे ln क्यों नहीं हो सकता? Okay, ln part will come later. Okay, don't worry about ln right now. Okay, ln part के बारे में हम बाद में देखेंगे. Now let's do a few examples. Let's say you have to integrate 2x plus 3, the whole thing to the power of 3. Okay, with respect to x. So first step, you add 1 to the power, 2x plus 3. So 3 plus 1 is 4. Divide by the new power, which is 4. Also divided by the differential of the bracket, which is going to be 2. So there you go. You can write it like this, 1 upon 8 into 2x plus 3 to the power of 4 plus c. Okay, and yes, you can also write it as 2x plus 3 to the power 4 upon 8 plus c. ठीक है, दोनों चलेगा. ln जो है ना, ln special cases में इस्तेमाल होता है. Okay, so what will that look like? I'll let you know. Now let's say you're asked to integrate square root of 2x plus 2. Okay, with respect to x. Again, before you integrate this, you have to first write it nicely. You have to first make sure that it's integratable, okay, or as I like to say, integration ready. Okay, so now it's integration ready. That means it's ready to be integrated, and that's what we're going to do. We're going to start integrating it. So you add 1 to the power, 2x plus 2 to the power of half plus 1. You use your calculator if you're afraid that you're going to mess it up. Half plus 1, in case you don't know, is 3 upon 2. So 3 upon 2, and also divided by the differential of 2x plus 2, which is going to be 2. So this 2 and this 2 gets cancelled out, and then don't forget the plus c. So your final answer, if you write it nicely, is going to be 2x plus 2 to the power of 3 upon 2 divided by 3 plus c. Okay, fellas, there you go. How long will the stream be? I don't know. Probably till 8. I don't know, maybe 7. Can't say anything. Okay? Because I don't have any other stream. The reason why I didn't plan any other stream is so that we can give a decent amount of time to integration. So I can't say how long it's going to be. Okay? As long as it takes, basically. Okay? Alright, now let's learn how to integrate the third type of functions, and that is exponential functions. Okay, now notice that the only examples that I'm doing are integration examples. We're not at the moment learning how to find the equation of the curve or anything like that. Okay, let's first learn how to integrate all types of functions, then those type of questions we'll do from past papers. Okay, because ultimately it boils down to how well you can differentiate and how well you can integrate. Okay, everything else is secondary. Yes, it's important, but ultimately it just boils down to how well you know the integration of functions and differentiation of functions. Okay, now here's type 3. Type 3 is integration of exponential functions. Yes, we'll do area under the graph as well. Don't worry about it. Okay. So let's do a recap of exponential functions. Now exponential functions बड़े अच्छे होते हैं क्यों? क्योंकि आप उसको कुछ भी कर लें, उसको आप जितना भी differentiate कर लें, उनको कोई फ़र्क नहीं पड़ता. ठीक है? I'm talking about just normal exponential functions, okay, without any power that have power only x. Okay. So for example, if let's say you have to integrate e to the power of ax plus b, okay. So before we learn how to integrate, let's learn how to differentiate it. Sir, while differentiating the numerator, can we get a variable in the denominator like we differentiate x square in the numerator? Can we get... Okay, I have no idea what you just said. So first let's recall differentiation. I'm afraid I failed to understand what your question is. So how would you differentiate this? So first things first, you write the function with the power as it is, then you multiply it by the differential of the power. Okay. So when you multiply it by the differential of the power, this is what you get: a e to the power ax plus b. Okay, this is what you end up with. Now, what about integration? In the case of integration, it's exactly the same, except that you don't multiply it by the differential of the power, you divide it by the differential of the power, and then you put a plus c. Okay, so there you go. This is what you end up with. Okay, now let's do a few examples here as well. So let's say you have to integrate e to the power of 5 minus 2x with respect to x. So that means e to the power 5 minus 2x as it is, divide by the differential of the power, which is going to be minus 2 plus c. So there you go. You don't even have to write it nicely. It's already written nicely. Okay. I mean, you can write it. Okay, yeah, you can write it like this if you want. Minus 1 upon 2 e to the power of 5 minus 2x plus c. Yeah, this looks nicer. So I would personally prefer it to write it. I would personally prefer to write it like this. Okay. Okay. Now let's say that you have something like this: 1 upon 2 e to the power 4x. Okay. How would you integrate this? Again, first of all, you'll make sure that it's written in a way that it can be integrated easily. So we'll let the 2 be as it is, we'll let the 1 upon 2 be as it is, and we'll bring e to the power 4x in the numerator, and as a result what happens is that the power becomes negative. Now please remember, I haven't integrated it yet, so that's why I've kept the integral sign intact. Okay. Now I'm going to start integrating it. So if I integrate this, here's what we get: 1 upon 2 e to the power minus 4x divided by the differential of the power, which is going to be minus 4, and then don't forget the plus c. Okay. So this, if you write it nicely, becomes minus 1 upon 8 e to the power of 4x plus c. Now who can explain what's happened from here to here? What just happened? I skipped a few steps, hoping that you guys would know what I've done, but let me know what I've done. Sir, is a u substitution method the best for integration? U substitution, that's not in add maths, that's in A2 math. Yep, I've used the rule of indices. I've taken the reciprocal. Okay, and that's what's happened. Now, in the denominator, it would be the positive power. Yes, that is correct. Okay. Now let's talk about integrating trigonometric functions. Okay, integration of trigonometric functions. Let's talk about that. And there are 3 trigonometric functions that we need to know the integration of: sine, cos, mainly sine and cos, but it's also important to know how to integrate sec square x. Okay. Okay, so before we learn how to integrate them, let's recap their differentiation. So like I said, sine x, cos x, and tan x. Now first we'll talk about the basic integral functions, okay, and then we'll talk about what happens when you have a certain angle with them. Okay. So let's say that you're asked to differentiate sine x. So how do you differentiate sine x? The differential of sine, remember, is cos. Okay. So it's cos x. Okay. Then how do you differentiate cos x? The differential of cos is minus sine. Now here's a little tip for you guys. Of all the things that students are afraid that they'll forget, this is, I would say, this is at the top of the list. Okay. The one thing that I've noticed that students generally forget is what the differential of sine will be and what the differential of cos will be. Okay. It's not. I'm sure that you guys aren't going to forget what the differential of tan is going to be. Okay. I haven't seen students forgetting that, but I have seen students forgetting the differential of sine and cos. So here's a little tip. As soon as you get the paper, just write this down. Okay. Write this down along with everything else that you're afraid that you'll forget. Okay. And from my experience, I've noticed that this is usually at the top of the list. Okay. Things that you're most likely to forget, this is, I would say, at the very top. So जैसे ही आपको paper मिले, just write this down immediately. Okay. Now what if you have a certain angle with them? Okay. What if there is a certain angle with sine, cos, and tan? Okay. So that's also important to understand. So if let's say you're differentiating sine, and the angle with sine is ax plus b. So let me make a square bracket over here. Sine, and the angle is ax plus b. So in that case, it's going to be sine of it's going to be the differential of sine. We'll do it in parts. So first we'll differentiate sine, which is going to be cos, and the angle will remain as it is, and then you'll multiply it by the differential of the angle, which is going to be a in this case. So you end up with a cos of ax plus b. Okay. Now what happens in the case of cos? So in the case of cos, if you have, let's say, d upon dx of cos of ax plus b, so in that case, it's going to be minus sine of ax plus b multiplied by the differential of the angle, which is going to be a, and now you have minus a sine of ax plus b. Okay, exactly the same thing. Acha, let me make some room over here for tan. The case of tan also isn't any different. Okay, it's the same. D upon dx of tan of ax plus b. Okay, so that is going to be sec square ax plus b multiplied by a. So you end up with a sec square of ax plus b. Okay, so this is how it works with tan. All right. Now what about the integral? The integral, if let's say, so let's skip the basic integral. Okay. So if let's say you have to integrate sine of ax plus b, so the integral of sine of ax plus b will be cos of ax plus b. Okay. No, wait a minute. The integral of sine is going to be minus cos. Okay. So it's going to be minus cos of ax plus b. And then in differentiation, we divide it by the differential of the angle. In integration, we divide it by the differential of the angle. And then don't forget the plus c. What about the integral of cos of ax plus b? Cos of ax plus b means the integral of cos is sine. So sine of ax plus b. And in differentiation, we multiply by the differential of the angle. In integration, we divide. And for tan x, sorry, not tan x. I'm sorry. It's sec square x. Integration of tan to nahi hai syllabus mein, it's sec square x. So if you're asked to integrate sec square, since the differential of tan is sec square, the integral of sec square is going to be tan. Tan along with ax plus b, and in differentiation we divide it by the differential of the angle. In integration we divide by the differential of the angle. So this is how you integrate trigonometric functions. Okay. How to integrate when power is minus 1? Okay. You don't need to know how to integrate when the power is minus 1. Okay, if you're talking about reciprocal functions, then that's not in our syllabus. Okay. And if you're talking about integration that leads to ln, then that's something else. Okay. That's something else which we'll cover later on. Okay, so let's do a few examples of this as well. Now let's say that you have to integrate the following. Do we have room over here? Yeah, we do. So let's say you have to integrate sine of 4x. Now, like I said, you don't have to memorize both, as in you don't have to memorize the differential and integral. Just memorize the differential and that's good enough. So if the differential of cos of x is minus sine, then the integral of sine x will be minus cos x. So that means this is going to be minus cos 4x divided by the differential of the angle, and then don't forget the plus c. So there you go. This is what you end up with. So let's do another example. Let's say you have the following: 3 cos 2x plus 1, and this is what you have to integrate with respect to x. Okay, so how do we integrate this? Remember, the differential of cos is minus sine, so the integral of minus sine is going to be cos, but this is cos. Differential of sine is cos, which means the integral of cos will be sine. So 3 as it is, we have sine instead of cos now, 2x plus 1 as it is, and we'll divide it by the differential of the angle, which is 2, and plus c. There you go. That's your answer. Okay, did I miss anything? Yes, application B is stream. Okay. So no. If you're talking about kinematics, applications where the applications part that we have in kinematics, then no, that I'll have a separate stream for kinematics, not in this one. Okay. Okay. Now let's talk about integration leading to ln. Okay, and that I think is the 5th. Okay, I forgot to number it. This is number 4. And now the 5th one, which is integration leading to ln. Okay, how does integration lead to ln? ये देखते हैं. So इसके लिए let's recap the differentiation of ln. So if let's say you're asked to differentiate ln x, okay, then how would you differentiate ln x? It's simply equal to 1 upon x. Also, if you're asked to differentiate ln of ax plus b, okay, then in that case what do? In that case, it's 1 upon the argument, 1 upon ax plus b, which you then multiply by the differential of the denominator, which is a in this case, and in that case, your final answer, if you write it nicely, is equal to a upon ax plus b. Okay? Okay. Now the question is, how does integration lead to ln? So in that case, the answer to that is when you have something like this, when you have 1 upon x, and if you're asked to integrate this, then what do you have? You have ln x, and then obviously don't forget the plus c. Okay. Now, what's the general rule behind this? Okay. How exactly do we know that we have to apply ln? Okay. So उसके लिए हम एक note लिख लेते हैं. Let's write a note for that. Okay. The note is this: when the differential of the denominator is present in the numerator, then the integral is found by using ln. Okay, so just remember this note. So this is what it looks like. If let's say you have a upon ax plus b, Now you can see here that if we differentiate ax plus b, what do we get? We get a. That means if I want to integrate a upon ax plus b, the answer will simply be ln of ax plus b. Okay, and then don't forget the plus c outside. Okay, अब इसको हम further generalize करके पता है कैसे लिख सकते हैं? We can further generalize it and write it like this. That if let's say in the denominator you have a function f of x, and in the numerator you have f prime of x, and you're asked to integrate this with respect to x, then in that case it's going to be ln f of x plus c. Okay, this is the general rule. Okay, now there are some questions where you have to sort of modify, do a bit of multiplication, division and stuff like that before you can make sure that the denominator, that the differential of the denominator is equal to the numerator. Okay, so we'll look into that as well. Yes, someone's already mentioned that. Okay, I don't know how you pronounce that, but yeah, we're going to look into that. Okay. So let's do a few simpler examples. Let's say you have something like this, 3 upon 3x plus 2. So if you look at the numerator, you can see the numerator is already the differential of the denominator, so you don't have to worry about a thing. Just write ln of the denominator and then put a plus c, and that's it, we're done. Okay, let's do another example. Let's say you have 2x plus 1, and in the denominator you have x square plus x minus 3. Again, if you think about it, if you differentiate the denominator, you'll notice that it's exactly equal to the numerator. Okay, so how exactly are you going to integrate this? It's simply going to be ln of the denominator, which means ln of x square plus x minus 3, and then just put a plus c, and that's it. Okay, but what if you have something like this? What if you have, let's say, 3 upon x? Okay, so what do you do in this case? So first of all, you tweak it in a way so that the numerator is nothing but the differential of the denominator. Okay, so that means I'm going to take this 3 and I'm going to take it outside. Now, if I take the 3 outside, then this is what we have, 3 into 1 upon x, and now this is the function that we're integrating. Okay, now can we integrate 1 upon x? Yes, we can. The integral of 1 upon x will be ln x, and then don't forget that you already have a 3 which is being multiplied. So it's going to be 3 ln x plus c, and that is your answer. Okay, now again, this was also a fairly simple question. Let's do another one. Let's say you have 4 upon 3 minus x. Okay, now what do I do with this? Again, step by step. First, let's take this 4 outside, and don't forget that we're integrating with respect to x. So this is what we're looking at, 4 into 1 upon 3 minus x. Okay, but the thing is, now if you think about the differential of the denominator, 3 minus x, that's going to be minus 1. And here, what do we have? Here we have a plus 1. So how will I make sure that the numerator is exactly equal to the differential of the denominator? For that, what I need to do is, I need to put a minus sign over here. Okay, and if I put a minus sign over here, then I can't just put a minus sign over here and let that be. Then I need to put a minus sign over here as well, so that the effect is balanced. Okay, if you just multiply it by minus and leave it there, then what you've done is you've changed the entire question. Okay, so in order to make sure that the balance is restored, okay, you multiply this by minus and then you multiply this by minus as well. Okay, so now what do we have? We can integrate this comfortably and say minus 4 ln of 3 minus x, and then don't forget the plus c. Now we'll do more questions like these. Okay, we'll do more questions like these. But अभी ज़रा पहले ये बताएं, यहाँ तक clear है? Statistics past papers. Are you talking about math? Statistics तो आसान है, नहीं? अच्छा, let me do another question. Let's say you have 7 upon 2x minus 1. Okay, 7 upon 2x minus 1. All right, and you have to integrate this. Now, the best practice is this. The best practice is that you first make sure that the numerator is 1. Okay, So how will you make sure that the numerator is 1? You'll take the 7 outside. So if you take the 7 outside, this is what you're looking at, 1 upon 2x minus 1. Okay. Now you have a new objective. Your new objective is to make sure that the numerator is equal to 2. Why? Because the differential of 2x minus 1 is equal to 2. Now the question is, how do I make it equal to 2? Well, you can make it equal to 2 by multiplying the numerator by 2. And if you've multiplied this value by 2, then what you're going to do outside, you're going to do the exact opposite. That means you're going to divide 7 by 2. Or you can do this. You can take the 7 and multiply it by half. Okay, remember, multiplying by 2 and dividing by 2 and multiplying by half is the same thing. So what I've done is I've multiplied this by 2 and I've multiplied this by 1 upon 2. So together, if you think about it, if you just compare half into 2, this will cancel out and the answer will be 1. But this helps us in a way that now the question becomes 7 upon 2 into 2 upon 2x minus 1. And this is what we're integrating with respect to x. So what do you get now? You get 7 upon 2 into ln 2x minus 1. And then don't forget the plus c. ठीक है, एक और example कर लेते हैं इसकी. Let's say you have something like this, 1 upon 3x plus 2. Okay, and this is what you have to integrate. Now what am I going to do over here? What do I need to do over here? That's the question you need to ask yourself. The answer to that should be that since the differential of the denominator 3x plus 2 is 3, that means the numerator should be 3. Now can I turn 1 into 3? Yes, I can very easily. All I have to do is multiply it by 3. Okay, but can I leave it at that? No, I can't. Now outside of the integral, I need to do the exact opposite of multiplying by 3, and the exact opposite of multiplying by 3 is multiplying by 1 upon 3. Okay, and now what happens is that this looks like 1 upon 3 integral of 3 over 3x plus 2 with respect to x, and now this is what we now have. Iska integral ab aasan ho gaya, is just going to be ln of the denominator 1 upon 3 ln 3x plus 2, and then don't forget the plus c, and that's your answer. Okay, IGCSE and O-level math papers are the same. Okay, you only have an extra February-March session in IGCSE. Other than that, the syllabus, everything is the same. Okay. Now what we'll do is we'll leave the hence find questions for later. Now let's do some past paper questions. And through past paper questions, we'll do some hence find questions as well. Okay? Kya khayal hai? What are your thoughts? 2 minute ka break लें. Murtaza, there's no need to do AS past papers for AdMath. I mean, AdMath के past papers खत्म हो गए हैं जो आप AS के कर रहे हैं. Just stick to AS past papers. All right. Yeah, as far as the concepts are concerned, more or less this is what you have. Okay. Now you have hence find questions as well. Okay. You have area under the curve as well. Okay. So we'll cover that through past paper questions only. Yeah, area under the curve questions, we'll do it through past papers. Time management, okay. So, भाई देखें, time management में वही सारी बातें हैं. Just don't waste any time, alright? No matter what happens around you, okay? Even if there is, let's say, I don't know, I mean, think of the worst possible thing that can happen, okay? Even then, you should not lose your focus, okay? And especially in AdMaths, it's very important because I'm talking about those, 8-9 mark questions. Usme, if you lose your focus, then what happens is you lose your chain of thoughts. So no matter what happens around you, just don't lose your focus for as long as you're not done with the question. Because if you lose your focus for even, let's say, 20 seconds, then you lose your chain of thoughts and then you'll have to start from the very beginning. No, maybe not from the very beginning, but like 2-3 steps backwards. You'll have to understand, okay, what area have you found? What are you doing? Are you adding, subtracting? What is it that you're doing? Okay, you'll have to do all of that. So my suggestion is And always plan your answer, especially when you're dealing with like we'll do some area under the curve questions. So I'll tell you how you can plan your answer. You need objectives for your question. You need to set objectives for yourself. Okay, you can't just have a head-on approach. Okay, I'm just going to start solving this question. No, that's not going to work. You need to break the question down, break the solution down into different objectives for yourself. Okay, like for example, if you're finding out the area under the curve again, so you need to see, do we have the equation of the curve? Great. Do we have the limits? Great. Do I just have to integrate the curve and that's it? That will give me the final answer. If yes, great. If not, then see what are the two areas you need to find, see whether you need to add them, subtract them, see what are the limits you need to apply. So break it down into smaller and smaller objectives. The better you do that, the more comfortable you will be while solving the question, and obviously the more likely you are to get the correct answer. So breaking the question down is very important. Now, as far as the questions that are like 4 or 5 marks are concerned, that's pretty easy. Okay, इसमें कोई problem नहीं है. And one thing that I mentioned in math as well, I'll mention it for maths. First, scan the paper. Do questions of the topic that you're most comfortable with. Do questions of the topic that are your strongest topic, because a lot of times it will happen that in between, or maybe sometimes at the very beginning, you will have a difficult questions and the easier questions may be at the very end. So it's very important that you first scan the paper, see where the easier questions are, do that, and then you do anything else. Okay, today I'm not going to be doing an O-level math stream. I'm just going to be streaming integration. Okay. Okay, so let's take a 2-minute break. I'll be back on my desk in 2 minutes. 2-3 minutes, okay? Not exactly 2 minutes, maybe 2-3 minutes. Uske baad we're doing past paper questions. Okay? So, see you boys and girls in 2 minutes. Okay. So, what did I miss? Yeah, ये जो भी अच्छी advice दे रहा है, get a good night's sleep, very important. Those of you who are saying panic and everything, I'm not saying the only reason why you panic is because you haven't had a good night's sleep, but it could be one of the main reasons, right? P1 is easier than P2? No, there's no such thing. If you're talking about add maths, then it's the same. Okay. There's no difference in paper 1 and paper 2. No permutation and combination today. I'll see if I can do that tomorrow, but definitely not today. Okay, today we're only going to do integration. Can we integrate 3 power x? No, you can't do that. You can't do that. I mean, you can, but you don't need to know how to do that. Okay. No, we won't do permutation and combination. I think I've already answered that question. Not today. We'll do it tomorrow. Tomorrow or day after. Can we do it day after? 21st, 22nd? Okay, it's pretty tight. Let's see. Okay, so let's start, shall we? Let's start with the questions one by one and see what's what. Okay. So you can download this worksheet from the description, and I'll upload the notes as well, which you can download. ठीक है, bismillah करते हैं, and let's start with the questions. Okay, so let's start with the first question. I haven't singled out the questions that I'm going to be solving, but we're going to try and do as many as possible. Okay. So here's the first question. Let's see what it says. And this is from major in 2011, paper 11. Okay. So it says a curve is such that dy by dx is so and so, where a is a constant. At the point 1, 4, the gradient of the curve is 2. Find the value of a. Okay. So we are given the gradient. Okay, we're given the gradient, and using the gradient, and we're also given the point where the gradient is 2. Okay, and through this information we need to find out the value of a. So basically, by reading the question, this means that dy by dx is equal to 2 when x equals to 1. So if you think about it, this is enough information to find out the value of a. So we replace dy by dx with 2, and we replace x with 1. So a e to the power 1 minus 1 minus 3 into 1 square. Okay, so let's see what do we get. 2 is equals to e to the power 0 is 1. So a into 1 is a minus 3. So what's a equal to? A is equals to 5. Okay. Then we have to find out the equation of the curve. Okay. Now, before we can find out the equation of the curve, let's write dy by dx with the value of a that we have found. So the value of a is 5 e to the power 1 minus x minus 3x squared. Okay. So we need to integrate this in order to find out the equation of the curve. So what happens when you integrate dy by dx? You end up finding y. So that's what we're going to do. Okay. And we're going to use all the rules of integration to integrate this. So 5 e to the power 1 minus x divided by the differential of the power 1 minus x, which is going to be minus 1, minus 3, you add 1 to the power, this is a power function, divide by the new power, and then don't forget the plus c. Okay, so this is what we get so far. Minus 5 e to the power 1 minus x cube plus c. Okay, now the question is, how do we find out the value of c? Now remember, in order to find out the value of c, you need a point through which the curve is passing. You always need a point through which the curve is passing. Okay, so we plug in 4 in place of y, we plug in 1 in place of x, so 1 minus 1 is 0, minus 1 cube plus c. So 4 is equals to minus 5 minus 1 plus c. Minus 5 minus 1 is minus 6. 4 plus 6 is equals to 10. So now you have y is equals to minus 5 e to the power 1 minus x cube plus 10 as the equation of the curve. So there you go, fellas. That's your answer. So what are your thoughts? Let me see if that's the end of the question. No, wait, it's not the end of the question. Okay, so let's not get carried away. So there's more. Okay, so here we have to integrate a composite function. So how do you integrate a composite function? 7x plus 8 as it is. You add 1 to the power 1 upon 3 plus 1. You divide by the new power. Now 1 upon 3 plus 1 is going to be 4 upon 3. And then don't forget that you also have to multiply it by the differential of 7x plus 8, which is going to be 7 in this case. So what do you have? You have 7x plus 8 to the power of 4 upon 3 over 28 upon 3 plus c. Now remember this, 1 divided by 28 upon 3 is going to be equal to 3 upon 28. So what this becomes is this, 3 upon 28 into 7x plus 8 to the power of 4 upon 3 plus c. And there you go, fellas. That's your answer. Okay, now let's do B part 2. Hence evaluate. Okay, so the reason why it's used the word hence is because you've already found the integral. Okay, now you know exactly where you're plugging in the limits. Okay, you're plugging in the limits in this. Okay, now whenever we are integrating within the limits, we don't consider the plus c. Why is that? Who can answer that? Why is it that whenever we are integrating within the limits, we don't consider the plus c? Sir, how did we get minus 1 in the denominator? We got minus 1 because 5 minus x, when e1 minus x, when you differentiate it, is minus 1. Differential of the power 1 minus x is going to be minus 1. Okay, now, so eight and 0. Yep, c gets cancelled out. So that's why we don't consider it to begin with. So we plug in 8. So 3 upon 28. Okay, so let's see what happens if you plug in 8 over here. So 7 into 8 is what? 56. 56 plus 6. 56 plus 8 is 64. So that means 3 upon 8 into 64 to the power of 4 upon 3. This is with the upper limit. Now if you plug in the lower limit, let's see what happens. 3 upon 28. 3 upon 28 with the lower limit plugged in. 0 into 7 is 0. 0 plus 8 is 8. So that means 8 to the power of 4 upon 3. Now you can evaluate this using your calculator. Okay. So 3, let's work this out. 3 upon 28 multiplied by 64 to the power of 4 upon 3. So that's equal to 192 upon 7. Okay. Minus, let's replace 64 with 8. Let's see what happens. So you get 12 upon 7. Okay. So the final answer is 192 minus 12, which is equal to 180. 180 upon 7 is your final answer. And there you go. That's it. That's your answer. Okay. Okay, there are some questions which I solved in the last stream where we did area under the curve. So I'm going to try and solve some unique questions only so we can save some time. Okay. I mean the questions that I didn't do earlier. So just a minute. Achha, let's solve this question. Kya khayal hai? What do you guys say? Should we solve this question? Yes, you can take 3 upon 28 common. Okay, you can do that. It's nothing to worry about. Whenever integrating an exponential function, we differentiate its power and take it as a denominator. But अभी तो पूरी कहानी बताई है. अभी तो मैंने बताया कि how to integrate exponential functions. Just rewind the stream, go back, and look at the concept. Okay, don't memorize it like that. All right. Okay, so let's solve this question. Here you also have to find out the area of the region enclosed by the curve and the line PQ. Okay, so let's do that. So here the question says, this has a bit of differentiation as well. Okay, the diagram shows part of the curve so and so cutting the y-axis at the point P. Okay, the curve has a minimum point at point Q. All right, so question for you guys, how do we find out the minimum point? Okay, if we have the equation of the curve and we're asked to find out the minimum point, how do we do that? How do we do that? Y equals to x cubed minus 9x square plus 24x plus 2. Differentiate, ठीक है, dy by dx equals to 0. Good job. So 3x square minus 18x plus 24, and we set this equal to 0. So 3x square minus 18x plus 24 equals to 0. Now you can use your calculator to solve this, okay, or if you don't want to use your calculator, just do middle term breaking. Okay, you can solve this very easily by middle term breaking. Plus 8 equals to 0. So factors of 8 that give you 6. So x equals to 4 or x equals to 2. Now the reason why we have 4 and 2 is because you can see that what we have done is we've actually found out the coordinates of the turning point, and we can see this curve is turning at 2 points. One of them is right here and the other is right here. So obviously ऐसा तो नहीं होगा, कोई बेवकूफ़ी होगा जो कहेगा ये 4 है ये 2 है, ठीक है. It's understood that this is going to be 2 and this is going to be 4. Okay, so that means as far as the x coordinate of q is concerned, we're going to go with 4 because q comes later. Okay, and how do I find out the y coordinate? Well, in order to find out the y coordinate, we're just going to plug in 4 back into the equation. So 4 cubed minus 9 into 4 square plus 24. You double differentiate. Yeah, nature is already stated. You're right. Plus 24 into 4 plus 2. Okay, so let's see what do we get. So the value of y that we end up with is equal to Taro. Let me check. So again, just use your calculator over here, save time. So 4 cube is 64 minus 9 into 4 square plus 24 into 4 plus 2. So y is equals to 18. There you go, y equals to 18. So we have the coordinates of q, 4 comma 18. And how many marks do you get for this? You get 4 marks, which I think is a pretty good deal. Okay, then it says find the area of the region enclosed by the curve and the line PQ. Okay, now let's clean this up. Let's take a screenshot of this. Okay, and let's bring this over here. Area of the region enclosed by the line and the curve PQ. Again, so for those of you who are asking me about time management tips, so this, make sure you look at the way that I'm solving this question. Okay, and I want you guys to do the same as well. Now, first of all, let's see what it is that you need to do in order to find out the area of the shaded region, okay, which is the area enclosed by the curve and the line PQ, okay, right here. Okay, so let's plan our answer. So in order to find out the area of the shaded region, what we'll have to do is we will first have to find out the area under the curve, okay, area under the curve within the limits. So notice that this is 4, we've already worked this out, and this is 0. So here's what we're going to have to do. First we will have to integrate, or first we'll have to find out the area under the curve, okay, and what are the limits that we're going to use? The limits that we're going to use will be 4 and 0, okay, and then from it we'll have to subtract this area. Now it's very important that you get the shape right, okay, if you want to use the shape. I personally prefer using the shape, okay. कुछ लोग पहले इसकी equation निकालेंगे and then they will integrate the line within the same limits. That's also perfectly all right, okay. But this shape, as you can see, is a trapezium. So what I'll do is from it I will subtract the area of trapezium. Now why is this a trapezium and not a triangle? Because this point right here, you can see, is slightly above the origin. Okay, this line is not cutting the origin, it's slightly above the origin. Okay, in fact, this point P, since it's the y-intercept of the curve, you can see that the y-intercept of the curve is 2. So you can actually find out the coordinates of P immediately, and they're going to be 0, 2. Okay, so that will save us some time. And we also have the coordinates of Q, so let's write that down, 4, 18. Now remember, it's either area of the trapezium or you can find out the area under the line. Okay, and my personal preference, like I mentioned, is to use the shape. Okay, now अब से फ़ायदा क्या हुआ? इससे फ़ायदा ये हो गया कि हमें एक डायरेक्शन मिल गया. Now we know in what direction we need to work in. Okay, and that's very important. Otherwise, it'll just be, we'll just be brainlessly integrating without any direction. So now we have a direction. We know that we have to find out the area of the trapezium. We know we need to find out the area under the curve. We know what limits we have to use. So it's much easier now. Okay, so now let's begin the integration part. So what we are integrating is this: x cube minus 9x square plus 24x plus 2, and we're integrating this within the limits 4 and 0. Okay, so how would you integrate x cube? It's going to be x power 4 upon 4, okay, minus 9x cube upon 3 plus 24x square upon 2, 24x square upon 2. Okay, just a minute. Let me just restart the app. Yeah, 24x square upon 2 plus 2x, और इसको हम इंटीग्रेट कर रहे हैं within the limits 8 and 0. Okay, sorry, not 8 and 0, 4 and 0. 4 and 0. And one another important tip is just keep checking your working as you go along instead of checking it at the very end. Okay. Now, the next step is that we need to simplify. Now, if you don't want to simplify, if you want to plug in the limit straight away, go ahead. Okay, but my suggestion is that you simplify it. Or maybe you can sort of skip that step partially and do that over here. Okay, and then you can plug in the limit. Okay, so this becomes x power 4 upon 4. So if we plug in 4, that means 4 to the power 4 upon 4. 4 to the power of 4 upon 4 minus 3 into 4 cube plus 12 into 4 square plus 2 into 4. And what happens if you plug in 0? If you plug in 0, you can see everything just becoming 0. Okay, so might as well not plug it in and might as well just leave it like that. Okay, now let's simplify this, and you can use your calculator over here to check your answer. ठीक है, calculator का इस्तेमाल मैं यहाँ पे highly encourage करूँगा, लेकिन remember the objective is what? The objective is to check your answer. So this gives us 24. Now, like I said, what I would like to do over here is I would like to check my answer. So I made a video on it as to how you can use your calculator to integrate within the limits. Okay, I'll just find it. जो मेरे shorts में मिल जाएगा आपको, ठीक है? So 24x plus 2 within the limits 0 and 4. Okay, so the answer actually is not 24. The answer is actually 72. ठीक है? It's not 24, it's 72. ठीक है, I made a calculation error, but yeah, it's 72. Yes, sets and Venn diagram is not in the syllabus. Okay, sets and Venn diagram is not in the syllabus, so yeah, just remember that. Okay, so मैंने गलती से 4 cube कर दिया था, I just realized. Let me just double check it. Okay, let me just double check and see my integral is also correct. Minus 3 into 4 cube plus 12 into 4 square plus 2 into 4. Yep, 72 is correct. Okay, 72 minus 0 is 72. Okay, so now we have the area under the curve. Now let's focus on the area under the line, or the area of trapezium. Now, it's a good idea to draw this trapezium separately. That's what I would recommend. Here is one parallel line, here's the other parallel line, the base is horizontal, and there you go. Okay, now this length will be what? This length will be 2, and this length will be what? This length will be 18. So that means the two parallel lengths are 2 and 18. Now what about the height? If the parallel lengths are vertical, that means the height is horizontal. Okay, so the height in this case is going to be 4. So let's find out the area of trapezium. Half into sum of parallel sides, that means 2 plus 18 multiplied by the height, which is 4. So 2 plus 18 is 20. 20 into 4 is 80, divided by 2, so that's 40. So 40 is the area of trapezium. Now, in order to find out the final answer, the area that's bounded by the line and the curve, okay, so that's going to be equal to 72 minus 40, which is equal to what? Which is equal to 32. And let's see if that's the correct answer. Yep, that's the correct answer. So there you go. That's that. Okay, you can find out the area under the line if you want, but like I said, for that you will first have to find out the equation of the line using the points P and Q, but a better way would be to find out the area of trapezium and subtract that from the area under the curve. Okay, all good? एरिया अंडर द लाइन ओके चलें अब अगर आप कह रहे हैं तो मैं कर देता हूँ so I'll do it over here. I'll find out the equation of the line and I'll tell you what limits to plug in, and then the rest you can do yourself. Okay, so the points that we're going to use are P, which is 0 comma 2, and Q, which is 4 comma 18. So find out the gradient. The gradient is going to be 18 minus 2 over 4 minus 2. 18 minus 2 is 16. 16 upon 2 is 8. Okay, so y is equals to 8x plus 2. अब 8x plus 2 को आप integrate करेंगे within the limits 4 and 0. Okay, now when you do that, when you integrate 8x plus 2 within the limits 4 and 0, you should get the same answer as the area of trapezium. Okay, so integrate 8x plus 2. This part I would encourage that you do it yourself within the limits 4 and 0. So you should get the same answer, and you'll let me see. Let me show you over here. 8x plus 2 within the limits 0 and 4. Yep, you get the. No, wait a minute. Oh, 16 upon 4 होगा. 16 upon 4. 16 upon 4 is 4. Okay. So integrate 4x plus 2 within the same limits, and you will get the same answer. Let me see if the answer is the same. Yep, you get 40. Okay. All right. Thank you. Thank you. That's basically why I don't encourage that. खैर वो एक silly error था, ठीक है, but it's just that it's a lot of working. Okay. All right. So do you guys want to do an insanely difficult question? अच्छा ये क्वेश्चन मैंने लास्ट स्ट्रीम में किया हुआ है, ठीक है, so I'm going to skip that. In fact, I've done this question also in the last stream, so I'm going to skip that. Okay, you guys can watch that stream to catch up. Let me see another question which I haven't solved in the last stream. Okay, let's solve this. So this is from May June 2014, paper 1, variant 2. Okay. Yes, I will do hence evaluate questions as well. Okay, don't worry about it. So it says here the region enclosed by the curve y equals to 2 sine 3x, the x-axis, and the line x equals to a, where a is in between 0 and 1. Okay, now why is the question telling this to us? Well, we'll find out. Okay, it might be that we end up with multiple values of a and we have to choose the one that's in between 0 and 1. Okay, it's possible. I'm not saying that's how it is, but it's possible. Okay, so according to the question, the region that's enclosed by the curve, the x-axis and the line x equals to a, where a is in between 0 and 1, lies entirely above the x-axis. Okay, that means it's all positive. Given that the area of this region is 1 upon 3 square units, find the value of a. Okay, so 2 sine 3x, okay, within the limits 0 and a is equal to what? Achha, why 0 and a? How did I know that the lower limit is going to be 0? Think about it. How did I know that the lower limit has to be 0? Why not something else? सोचने की बात है ना. I mean, how did I guess that the lower limit is going to be 0? Or do I know for sure? Okay, so Mohammed Sarmad, why are you looking for ASP1 videos? You'll find AS live streams, okay? You'll find a lot of AS live streams where I've covered equation of circles, EPGP, and other topics as well, okay? Functions as well, yeah. X-axis, no. No, that's not how I know. The reason why I know that it has to be 0 is because if you look at the graph of 2 sine 3x, where is it going to start from? It has to start from 0. Okay, it has to start from 0, and a, which is in between 0 and 1. Okay, so a is in between 0 and 1, so maybe it's somewhere over here, and the question told us in fact that this part of the curve lies entirely above the x-axis, and the area of this region is 1 upon 3. So that's how I know. That's how I know that the lower limit has to be 0. Okay, if the lower limit was other than 0, the question would have categorically mentioned. Okay, the question would have categorically mentioned that bounded by the two lines. One of them would be x equals to a, and the other line would be something else. A is on the x-axis. Okay, the line x equals to a is a vertical line, so that means a is on the x-axis. Okay, this is the region that has area 1 upon 3. Okay, ये region है जिसका area 1 upon 3 के बराबर है. All right. Okay, now let's start integrating this. What will be the integral of sine? The integral of sine would be, now remember it this way, the differential of sine is cos, the differential of cos is minus sine, that means the integral of sine would be minus cos. Okay, so minus cos, minus 2 in fact, minus 2 cos 3x divided by the differential of the angle, which is 3, within the limits a and 0 is equal to what? Is equal to 1 upon 3. Okay, so like I said, just remember this, that the differential of sine is equal to what? Is equal to cos, and the differential of cos is equal to what? Is equal to minus sine, which means that the integral of sine will be equal to minus cos. Okay, okay, now let's plug in the limits. So minus 2 cos 3a upon 3 is the upper limit plugged in, and now let's plug in the lower limit. So if you plug in the lower limit, that means minus 2, and make sure that your calculator is in radian mode. Okay, make sure your calculator is in radian mode because the question says so. Minus 2 cos 3 into 0 divided by 3. So here's what we get, minus 2 upon 3, which is equal to 1 upon 3. Okay, so this is with the lower limit plugged in. Let me double check. Minus 2 cos 0 upon 3. Yep, it's minus 2 upon 3. Okay, so we have minus 2 cos 3a upon 3 plus 2 upon 3, which is equal to 1 upon 3. Now you take 2 upon 3 over to the other side. So minus 2 cos 3a upon 3 is equal to what? 1 upon 3 minus 2 upon 3. Now what's 1 upon 3 minus 2 upon 3? That's equal to minus 1 upon 3. So the two negatives get cancelled. Okay, the upon 3 and the upon 3 also gets cancelled. And now this is what we're looking at. We're looking at cos 3a, 2 cos 3a equals to 1, which means we're looking at cos 3a, which is equal to 1 upon 2. Okay, now cos is positive, and what do we have? We have to find out 3a. Okay, and if cos is positive, that means it's going to be in the first quadrant or the fourth quadrant. Now let's find out alpha. How do we find out alpha? We take cos inverse of 1 upon 2, which is going to be equal to 1 upon 3 pi. So if it's 1 upon 3 pi, what does that mean? That means in the first quadrant, 3a is going to be the same as 1 upon 3 pi. And it's also possible that it's in the fourth quadrant. Okay, now if you've already figured that out, that this is something we shouldn't consider, then that's great. But if you haven't, don't worry about it. So how will I find out this angle? I'll simply do 2 pi minus answer. So 2 pi minus answer gives me 5 upon 3 pi. Now the two potential values of A are actually pi upon 9 and 5 upon 9 pi. Now which of these values you think will be in between 0 and 1? Remember, this was the condition given to us in the question. So which of these two values do you think is in between 0 and 1? Oh, I just saw crossed 47,000. Chale, that's great. Thank you, everyone. Oh, it start decrease होना शुरू हो गया. Khair, anyway, how do I know it has to be in between 0 and 1? I mean, well, that I know. How do I know which value is in between 0 and 1? Yeah, pi by 9 is the correct answer. So that means A has to be in between. A has to be pi upon 9 only. Okay. Achha, sir, I don't understand the 2 plus 2 minus. What do you mean? Oh, this is not plus minus. It's just that we had minus on both sides, so it just got cancelled. Okay. It's not a plus minus. We had a minus on both sides, so we just cancel it out and made it plus. ठीक है. So there you go, boys and girls. What are your thoughts on this? Easy? Medium? Difficult? चलें एक और ज़रा मुश्किल सवाल करते हैं. Let's do another insanely difficult question. Okay. Let's do this one, and then we'll do a question where we have to deal with ln. Okay. We'll do a question where we have to deal with ln. Went through my head, really? Okay, not what I had in mind, but चलें. Hence वाले बाद में करेंगे. First, let's get a good grip on this. Okay. We'll do the hence find later. Okay. So here's a question. This is okay. ठीक है. Now I get it. So basically, this question starts off like a polynomial question, okay, and then you have a area under the, then you have an integration question, okay. Now the polynomial part is only going to help us over here, okay. So let's see how we can do this. So how do you show that x minus 2 is a factor? So you take x equals to 2 and you plug it in the function. So 3 into 2 cube, okay, minus 14 into 2 square plus 32, okay. So if it is a factor, which it is since we're supposed to show it, so that means it definitely is, that means our final answer should be equal to 0. So it's equal to 0, that means x minus 2 is a factor. Okay, now how will I factorize this completely? Factorizing this completely basically means that we need to find out all the other factors, okay. Now how do I find out all the other factors? You can use long division, you can use synthetic division, you can use identities, you can do whatever you want, okay. So I'm going to go with long division. Synthetic division allowed hai, so a lot of students ask whether synthetic division is allowed or not, but it's allowed. It is allowed, but my suggestion still is that do long division, okay. So x minus 2 is what we're dividing it by. So how do I turn x into 3x cubed? We need to multiply it by 3x square. So this becomes 3x cubed minus 2 into 3x square becomes minus 6x square. Okay, when you subtract the 2, this gets eliminated. And minus 14 minus minus 6, minus 14 minus minus 6 is minus 8x square, and the plus 32 as it is brought down. Now what do I need to multiply x with in order to turn it into minus 8x square? The answer to that is minus 8x. This becomes minus 8x square plus 16x. Now if you subtract the 2, this gets eliminated, and now you have 32 minus 16x, which you can write it nicely and say minus 16x plus 32. Now what do I multiply x with in order to make it minus 16x? The answer to that is minus 16, which makes it minus 16x plus 32. And when you subtract the 2, it gets eliminated, and the denominator is not 0 by coincidence. It was supposed to be 0 because we're dividing it by none other than its factor. Now this is the equation which we're now further going to factorize, and 16 into 3 is 48. Factors of 48 that leave us with minus 8 are going to be 12 and 4. So minus 12x plus 4x minus 16. You take 3 along with x common, so we have x minus 4, and then you take 4 common, so you have x minus 4 as well. So you have 3x plus 4 into x minus 4, which is as a result of factorizing the quotient. And don't forget that you also had x minus 2 from before. So your final answer is x minus 2 into 3x plus 4 into x minus 4. Okay, so there you go. Okay, now then it says the diagram below shows part of the curve y equals to 3x minus 14 plus 32 upon x square, cutting the x-axis at P and Q. Okay, state the coordinates of P and Q. So how will I find out the coordinates of P and Q? The coordinates of P and Q are basically the x-intercepts. Now notice, why is this a 1-mark question? This is a 1-mark question because most of the work that's required to find out the coordinates of P and Q has already been done. Okay, since P and Q are the x-intercepts, that means y is going to be equal to 0. Okay, ab dekhna, something interesting will happen when you take the LCM. When you take the LCM, it's going to be x square. Okay, so this becomes 3x square minus 14. No, wait, this becomes 3x cube minus 14x square plus 32, which is equal to 0. And now you are left with the equation 3x cube minus 14x square plus 32 equals to 0. Okay, don't start solving this equation all over again because you've already done that. In the previous part, you've already factorized it. It's 3x cube minus 14x square plus 32 equals to 0. So now you know that this equation can actually be written like this. This equation can, 3x cube, sorry about that. This equation can actually be written as x minus 2 into x minus 4 into 3x plus 4 equals to 0. Okay, so we don't have to solve it all over again. That's the reason why it's a 1-mark question. So x equals to 2, x equals to 4, and x equals to minus 4 upon 3. So obviously the x coordinate of P is not going to be minus 4 upon 3. It's going to be 2, and just like that, the x coordinate of Q is going to be 4. Okay, so there you go. The x coordinates are 2. Okay, this is the x coordinate of P, and the x coordinate of Q is equal to what? Is equal to 4. And there you go. That's your answer. Okay. And hence determine the area of the shaded region. Okay. So in order to find out the area of the shaded region, we know that we will have to integrate y within the limits 4 and 2. But remember, what we also have to do is at the end, we need to multiply it by minus. Why is that? Because the area that we're trying to find out is actually below the x-axis. Okay, is actually below the x-axis. Okay. Now, so first we need to integrate, then we will find out the area. So before I can integrate, we have to write it in a way so that it's easy for us to integrate, basically make it integration ready. So 32x to the power minus 2. Now we begin the integration part. So this becomes 3x square upon 2 minus 14x plus, now be careful over here, especially with the signs, 32x to the power minus 2 plus 1 is minus 1. divide by the new power, which is also minus 1. Achha, limits part will come later. And then don't forget the plus c. So I'm going to write this nicely. 3 upon 2x square minus 14x plus in fact minus 1 upon 30, no wait a minute, minus 32 upon x. Yeah, minus 32 upon x. And then don't forget the plus c. Okay, so here's what's happened. This plus and minus has made the overall value minus, and x bar minus 1 from the numerator has shifted into the denominator, and that's why we have the power as positive. Okay. Okay, integration with modulus, no plus c. Okay, we haven't plugged in the limits yet. Okay, read the question. It says find this and hence determine the area of the shaded region. So at the moment, I've only found out the integral. Now when I plug in the limits, that is how I will get the area of shaded region. Okay, so I'm going to do that now. I'm going to plug in the limits. Okay. So let's plug in the limits, see what do we get. Now when we are plugging in the limits, you're right, we're not going to consider the plus c. So 3 upon 2x square minus 14x minus 32 upon x within the limits 4 and 2. Okay, and in the end, just don't forget to multiply your answer by minus. Okay. Alright, so let's plug in the upper limit. 3 upon 2 into 4 squared minus 14 into 4 minus 32 upon 4. So this is with the upper limit plugged in. And now let's plug in the lower limit, which means 3 upon 2 into 2 square minus 14 into 2 minus 32 into divide by 2. Okay, so this is the lower limit plugged in. So don't we multiply minus 1 for area above the curve? No, we multiply by minus 1 for area below the curve. Okay. So 3 upon 2 into 4 square minus 14 into 4 minus 32 upon 4. So here we have minus 40. Okay. So minus 40 is with the upper limit plugged in. Let's see what do we get with the lower limit plugged in. So I'm just going to change 4 to 2. So you get minus 38. So minus 40 minus minus 38 becomes minus 38. And like I said, don't forget that in the end you have to multiply it by minus. So minus 40 plus 38 becomes minus 2. And when you multiply it by minus, the final answer is 2. So this 2 is the area of shaded region. There you go. Nahi Maria, it's not 78. You probably made a plus minus error. So what are your thoughts on this question? So you guys want to do an insanely difficult question with ln, and then we can maybe do hence find questions as well. What do you say? Yes, applying modulus and negative sign is the same. Yes. Thoughts finished. Khatam ho gaya thoughts. Sir, if the limits form a positive term, so will we multiply by minus? Okay, if the area is below the x-axis, then it's not possible that your answer turns out to be positive. It's inevitable that the answer is going to be negative. Applying the modulus and the negative sign. Yeah, I've already answered that. It's the same. No, if it was minus 38 plus 40, then there's no need to multiply it by minus. The only time where we multiply it by minus is when the area that we're trying to find out is below the x-axis. And if the area that we're trying to find out is below the x-axis, then remember, your answer should be negative. And if it's not, that means you're doing something wrong. Okay, fellas, all good? Okay, let's move on. फास्ट जा रहे हैं बेटा, एग्ज़ाम में 2 दिन है, तो आप क्या सोच के आए थे? Okay, let me see if I've already solved this question. No, I haven't. Okay, now let's solve this. Okay, this is from October-November 2021, paper 12. Okay, so it says here, the diagram shows the graph of the curve so and so for x is greater than -2. The points A and B lie on the curve such that the x coordinate of A and B are -1 and 2 respectively. Okay, find the exact y coordinates of A and B. Okay, so we can do that. So if you want to find out the exact y coordinate of A, for A, remember x equals to -1. So we're going to plug in -1. So that means 1 upon -1 plus 2, the whole thing square, plus 3 upon -1 plus 2. So this is what we get. 1 upon -1 plus 2 is 1, square of which is 1. And 3 upon -1 plus 2 minus 1 plus 2 is again 1. And 1 plus 1 divided by 3. 3 divided by 1 is 3, and y equals to 1 plus 3, which means y equals to 4. So the y coordinate of A is equal to what? Is equal to 4. Now let's talk about B. The x coordinate for B is x equals to 2. So that's what we're going to plug in now. So 1 upon 2 plus 2, the whole thing square, plus 3 upon 2 plus 2. Okay, for this, I would strongly suggest that you use a calculator. So 1 upon 2 plus 2, the whole thing square, plus 3 upon. Okay, so you get y equals to 13 upon 16. Okay, there you go. That's your answer. Okay, then it says, find the area of the shaded region enclosed by the line and the curve. Okay, so this is what we have to find. Yeah, find the area of the shaded region enclosed by the line AB and the curve, giving your answer in the form of P upon Q minus L and R, where P, Q and R are integers. Okay, now so let's see what we can do over here. We need to find out the area of shaded region. Again, let's plan our answer. Now this question again is very nice in the sense कि उसने हमसे अच्छी खासी मेहनत ऑलरेडी करवा ली है, लेकिन अच्छी खासी अभी बाकी भी है. Okay, so first we need to find out the area of trapezium, and from the area of trapezium we need to then subtract the area under the curve. Okay, so let's write that down, and that's going to give us our area of shaded region. So area of shaded region is equal to what? Let's color code it as well. Area of trapezium and from it we minus the area under the curve. Okay, now first let's find out the area of trapezium. Okay, first let's find out the area of trapezium. Okay, so for that, the working that I'll do it in green. Now it's always a good idea to draw the trapezium separately. Okay, now here is one parallel length, here is the height, here is the other parallel length, and here is the fourth length. Now one parallel length will basically be equal to the value of A, okay, which turned out to be what? Which turned out to be 4. The y coordinate of A turned out to be 4. Okay, so that means this is 4, and the other height is going to be, sorry, the other parallel length is going to be the y coordinate of B, which turned out to be 13 upon 16. Okay, that's what I wrote. Yeah, 13 upon 16. And then the height is basically stretching from -1 to 2. So that means the height of this trapezium is going to be 3. 2 minus -1, so it's going to be 3. Okay, now let's find out the area of trapezium. Half into sum of parallel lengths, which means 4 plus 13 upon 16 multiplied by the height, which is equal to 3. So let's see, what do we get? 1 upon 2 into 4 plus 13 upon 16 multiplied by the height, which is equal to 3. So what we have is this, 231 upon 32. Okay, so what's that? That's the area of trapezium. Now from it, what do we need to subtract? We need to subtract the area under the curve. Okay, so how do I subtract the area under the curve? Now that is something that's going to take a while. Okay, that's something that's going to take a while because the equation of the curve is quite complex. That means we're integrating y within the limits 2 and minus 1. Okay, which basically means that we are integrating 1 upon x plus 2 the whole thing square plus 3 upon x plus 2 within the limits minus 1 is 2. Let me double check that. Yeah, 1 upon x plus 2 the whole thing square plus 3 upon x plus 2 within the limits 2 and minus 1 actually. Yeah, 2 and minus 1. Okay, now I hope you guys are ready. Let's begin the integration. Now before I start off with the integration, I need to make sure that it's written in a way that it can be integrated easily. So I'll shift the x plus 2 in the numerator and the power as a result will become positive. Okay, and here I will take the 3 outside and we'll just have 1 upon x plus 2. Okay, and remember all of this is within the limit. No, wait a minute actually. Yeah, so all of this is within the limit 2 and minus 1. Okay, now let's start the integration part. So x plus 2 to the power minus 2 plus 1, which is going to be minus 1, divide by the new power, which is minus 1, plus 3. Now how would you integrate 1 upon x plus 2? That's just going to be ln x plus 2. Okay, and don't forget that the limits that you're going to plug in are basically 2 and minus 1. Now my suggestion would be that before you plug in the limit, you just write it nicely. Okay, so this can be written as 1 upon x plus 2, okay, plus 3 ln x plus 2, okay, within the limits 2 and minus 1. Okay, now I'm going to start from here. So if you plug in 2, let's see what happens. Minus 1 upon 2 plus 2, which means 4 plus 2, plus 3 ln 2 plus 2, which means ln 4. Okay, so this is what we end up with so far. Now, then we have 2 plugged in, then we have minus 1 plugged in. Okay, so this is with the upper limit plugged in. Now let's plug in the lower limit. So minus 1 over minus 1 plus 2, which means minus 1. Sir, why you didn't do x plus 2 to the power minus 1? Well, I turned it positive so that it's easier to plug in a value. You could have done it like that. The answer would have been the same. Okay. Yeah. So minus 1 upon minus 1 plus 2. Okay, minus 1 plus 2 is not going to be minus 1. Minus 1 plus 2 is actually going to be 1. Okay. And then you have plus 3 ln minus 1 plus 2 is ln 1. There you go. Okay. Now let's simplify this. See what do we get? Minus 1 upon 4 plus 3 ln 4 plus 1, because minus into, so basically this will become minus 1 plus 0. Why 0? Because ln 1 is 0. So now that's why we have the plus 1. Okay, so now minus 1 divided by 4 plus 1 is 3 upon 4. So that means this is what we're looking at, 3 ln 4 plus 3 upon 4. Now this is just the area under the curve. Okay. Now to find out the area of shaded region, remember we said is going to be area of the trapezium, which turned out to be 231 upon 32, and from it we're going to subtract the area under the curve. That means minus 3 ln 4 plus 3 upon 4. So 231 minus 3 upon 4 turns out to be 231 upon 32. Minus 3 upon 4 turns out to be 207 upon 32 minus 3 ln 4. Acha, if we go back, the question said that your answer should be P upon Q minus the plus the minus ln R. So how do I bring it in this form? What do I have to do? There's just one extra step that we have to do in order to bring it in this form. No, I will not recommend that you take extra sheets. Okay, you won't need extra sheets. Okay. Yep, 4 की power 3. So 207 upon 32 minus ln 4 cube. And what's 4 cube? 4 cube, as we know, is 64. So 207 upon 32 minus 4 cube, which means minus ln 64. And there you go, fellas. That's your answer. So what are your thoughts? Messiah? Okay. Scrumptious. My brain is missing content. Okay, I will. Don't expect a call anytime soon. Call it a day already? I thought you guys wanted me to do hence find questions as well. Yeah, I'm looking for a hence find question, don't worry. Hence find questions normally differentiation में होते हैं. इस past paper में पता नहीं होंगे नहीं होंगे. But I came across one question. Okay, this is interesting. Let's do this. Okay, now, so we have to differentiate this. Now I'm expecting you guys know your differentiation well. Okay, so what's u equals to? U equals to x square, which means u prime is going to be equal to 2x. Okay, v equals to what? V equals to ln x, which means v prime is equals to 1 upon x. Okay, now how do you differentiate something like this? It's going to be vu prime plus uv prime. So that means ln x into 2x plus x square into 1 upon x. Okay, so this is what dy by dx is going to be equal to. Now let's write this nicely. 2x ln x plus x square upon x, which you can simplify and write as simply x. So this is what you get. Okay. Okay, now remember there's a trick which you need to use in order to find hence find questions. Okay, don't just brainlessly start solving them. Okay, you have to use the answer to the previous part. Okay, now after solving the first part, what do we now know? We now know that differentiating x square ln x leads to 2x ln x plus x. Okay, which means consequently integrating 2x ln x plus x will lead to x square ln x. Okay, does everyone understand this? That if you differentiate, like for example over here, if you differentiate 2x, what do you get? In fact, not 2x. If you differentiate x square, what do you get? You get 2x, which means consequently that if you integrate 2x, you get what? You get x square. And don't worry about the plus c part. Okay, obviously you get a plus c, but this is what's more important. So ये बताएं सबको समझ आया? आवाज़ कम आ रही है? Is that the case? बेटा I think आपके end से कोई मसला है. Here the audio seems fine. अगर doubt हो, just use a pencil so you can erase it if you need to. There's also a blank page. Okay, यहाँ तक तो easy है. ठीक है, great. Okay. Now, here's a new objective. The new objective is that you now have to bring the left hand side equal to what you actually have to find the integral of. Okay, so I'll write that down. Type कर देता हूँ चलो. Now bring the left hand side equal to what you actually have to find the integral of. Okay, let's make it left align. Okay, there you go. So that's what I'm going to do now. I'm going to bring the left hand side equal to what I actually have to find the integral of. Okay, so far I've only differentiated, and using differentiation I've been able to conclude that if I differentiate x square ln x, I end up with 2x ln x plus x, which means that if I integrate 2x ln x plus x, I end up with x square ln x. Okay, and don't forget to make a bracket over here. All right, now so step by step I will bring the left hand side equal to x ln x. So 2x ln x, okay, 2x ln x plus the integral of x. So what I've done over here is I've separated it. Okay, so मैंने क्या किया, मैंने यहाँ पे इसको separate कर लिया. Plus x is equal to what? Is equals to x square ln x. Now remember, eyes on the prize. What's the prize? This is the prize. This is what we have to bring the left hand side equal to no matter what we do. Okay, now 2x ln x is equal to what? Is equals to x square ln x minus the integral of x. Okay, so we're almost there. Now this 2 we need to get rid of. Why do we need to get rid of this 2 here? Because notice that we have x over here and here we have 2x. So how do I get rid of this 2? So in order to get rid of this 2, I divide this by 2. Okay, or you can think of it this way, that I multiply the left hand side by 2, and as a result I multiply the right hand side by I multiply the left hand side by half, and I multiply the right hand side by half as well. Okay, or you can think of it simply this way, कि ये 2 इधर multiply हो रहा है, take it across the equals to sign, so it gets divided. Okay, now if you simplify this, you have x square ln x as it is, and what will be the integral of x? It's going to be x square upon 2, and then don't forget that you also have to multiply it by half. So what happens now is this: you have half x square ln x minus x square upon 4 as your final answer. Why? Because this is equal to what? This is equal to x integral of x ln x. Okay, now take a good look at what I've done. Let me know if you have any questions. Yeah, that's the correct answer. Yeah, I'll do more questions like this. Don't worry about it. चलो ये करते हैं. Okay, this is question number 22. देखो objective clear होना चाहिए. Okay, if your objective is messed up, then you will never know what to do. Your objective is to use the first part where you've already differentiated something. That means what you've obtained after differentiation. If you integrate that, you go back to the question which you differentiated. Okay, so now your objective is to bring the left hand side equal to what you actually have to integrate. Okay, so I'll do another question. Let's do this question. This is question number 22. Let's see what do we have over here. So let's differentiate this. Okay, so if you differentiate e to the power of 2 minus x square. Okay, so what happens? You have e to the power of 2 minus x square as it is, and you divide it by the differential of the power, which is going to be minus 2x, and then don't forget the plus. No, wait, differentiate current. Obviously, there's not going to be any plus c. Okay, Achha, oh, you're supposed to multiply it by minus 2x. Okay, sorry about that. Now, this is what you end up with. You end up with minus 2x e to the power of 2 minus x square, and according to the question, you should end up with kx e to the power of 2 minus x square. So comparing the two, you can see that k is equals to what? K equals to minus 2. Okay. Now, after part 1, this is what you know. You know that if you differentiate, if you go the extra mile, even though sometimes the amount of working that you do won't do justice to the number of marks, but going the extra mile will at least guarantee that you're doing it right. So now you know after part 1 that if you differentiate e to the power of 2 minus x square, you end up with minus 2x e to the power of 2 minus x square, which means now consequently I also know that if I were to integrate minus 2x e to the power of 2 minus x square, I will end up with what? I will end up with e to the power 2 minus x square. Okay, this is what we know after the first part. All right. Now, अब हमारा objective क्या है? Now our objective is to change this minus 2 to 3 somehow. Okay. So first things first, let's entirely get rid of the minus 2 sign. Okay. How do I entirely get rid of the minus 2 sign? Take it outside, or you can take it across the equals to sign and then divide it by minus 2. Okay. So either way, I need to get rid of it. Okay. So after you get rid of the minus 2 sign, x e to the power 2 minus x square is now equal to e to the power of 2 minus x square upon minus 2. Now I hope everyone understands this step over here. I've taken this minus 2 from here and taken it across the equals to sign. It's like multiplying the left hand side by minus 1 upon 2 and multiplying the right hand side by minus 1 upon 2 as well, so that we can just get rid of this. Okay, so I hope that's clear. Okay, then we need to turn this x into 3x. How do I turn this x into 3x? I multiply the left hand side by 3, okay, and I multiply the right hand side by 3 as well. Okay, so now we know the integral of 3x e to the power 2 minus x square is equal to what? Is equal to minus 3 upon 2. So I've written the minus sign with the numerator. That's how we normally write it. E to the power of 2 minus x square. There you go. Minus 3 upon 2 e to the power 3 minus x square, and then don't forget the plus c. So this is more like, if you notice over here, we're not using some hardcore concepts of integration. We're using more concepts of algebraic manipulation. That's what we're using over here. We're barely using any concepts of hardcore integration. We're using more concepts of differentiation. Oh, we're using more concepts of algebraic manipulation. Okay, you guys want to do another question like this? चलो ये करते हैं. Oh, this is a good question. So how will I differentiate this? How are we going to differentiate this? Break. You guys want to break? Really? But I don't think it's the computer. I think it's your brain that's lagging. Product law. Yep, we're going to use product law. Okay, now, so here's what we're going to do. We're going to differentiate this. Okay. So how exactly are we going to differentiate this? We're going to use product rule. Okay. Chain rule. What do you mean by chain rule? Okay. Anyway, so u is going to be chain rule. So उसमें आता है, rates of change में आता है. अच्छा, okay. I know what you're calling chain rule. Okay. So this becomes 4x cube. Acha. Now v is basically equal to sine to the power of half x. Now, I hope you guys know how to differentiate this. So v prime is going to be equal to half of sine to the power of half x. Okay. Sine to the power of half minus 1x. Okay. And then multiplied by the differential of sine, which is equal to cos x. Okay. Now it's important that you write this nicely. So this is going to be equal to cos x. Now because the power on sine will be half minus 1, which is minus 1. So as a result, you will have 2 sine to the power of half x, which instead I would prefer to write as 2 square root of sine x. Okay. I would prefer to write it like this. Okay. So can we do synthetic division? Yeah, you can do synthetic division as well. Okay. All right. Now, so vu prime plus uv prime is what the differential is equal to. So vu prime, now I would prefer to write it back as square root of sine x. So 4x cube into square root of sine x. Okay. Acha. Then what do we have? Then we have x power 4 upon 2. Okay. So x plus x to the power 4 upon 2 into cos x upon square root of sine x. Okay, now before I move on, let me make sure this is correct. 4 upon, yeah, x power 4 upon 2 cos x over sine x. Okay, this is correct. Okay, so this is the differential. Okay, now after part 1, here's what we know. After part 1, we know that if we differentiate x power 4 into square root of sine x, okay, we get the following. We get 4x cube square root of sine x plus x power 4 upon 2, okay, plus x power 4 upon 2 cos x upon square root of sine x. Okay. So that means from part 1 only, here's what we can conclude. We can conclude the following. We can conclude that if we can do the following, we can integrate 4x cube square root of sine x, okay, plus x power 4 upon 2, okay, cos x upon square root of sine x. Then this is what we end up with. We end up with x power 4 into square root of sine x. Okay, this is what we end up with. Okay, now I hope all is well so far. This question is a complicated one, but I hope it's clear. Okay, now notice that what we are actually supposed to integrate is slightly different from what we now know. Okay, what we're supposed to integrate has a plus x as well. Okay, अब ये ना इसमें ज़रा थोड़ा सा कॉम्प्लिकेटेड सीन है. ठीक है, मैं आपको बताता हूँ क्यों. इसको हमें ज़रा थोड़ा सेपरेट करके लिखना पड़ेगा. इसको अगर हम सेपरेट करके लिखेंगे, सो दैट मीन्स वी हैव इंटेग्रल ऑफ x प्लस द इंटेग्रल ऑफ एवरीथिंग एल्स. x पावर 4 cos x upon square root sin x, okay, plus 8x cube into square root of sin x. ठीक है, so that's what I've done. I've separated it. Okay, because what we have to find the integral of is not exactly equal to what we know. Okay. Now first things first, and that is we are actually going to bring this. Okay, we're going to bring this equal to this. Okay, I'm going to bring the left hand side equal to what we need to find the integral of. Okay, now if you make an observation over here, you notice that we have 4 over here and we have 8 over here. अच्छा मैं काम करता हूँ, let me just change the order slightly. Let me just change the order slightly so it's easy for you guys to see what I'm doing. Yeah. Okay, so I've just changed the order slightly. So x power 4 upon 2 cos x upon square root sin x plus 4x cube into square root of sin x equals to this. Now notice कि ये जो है यहाँ पे we have x power 4, we don't have the upon 2, and we have 4 over here, we don't have the 8. So what do I need to do in order to bring this equal to this? What do I need to do? I need to multiply by 2. Okay, I need to multiply it by 2. So if I'm multiplying the left hand side by 2, that means I'm going to multiply the right hand side by 2 as well. अच्छा अब मैं इसको drag करके मैं यहाँ पे लेके जा रहा हूँ, ठीक है? So I'm gonna put this inside a box. We'll deal with this later. Okay. Now when we multiply it by 2, that means the left hand side becomes what? The left hand side becomes 2x to the power of 4 upon 2, or might as well just write it as x power 4. X power 4 into cos x upon square root of sin x plus 8x cube into square root of sin x, which is equal to what? Which is equal to 2x power 4 into square root of sin x. Okay. Now अब note करो, we know part of the answer. We know that the integral of x power 4 cos x upon root sin x plus 8x cube root sin x is equal to what? Is equal to this. Okay, so that's what I'm going to do. What I'm going to do now is, let's bring this back over here. Now we know what this is equal to. Okay, this is equal to this. So this is equal to root x plus integral of x plus 2x power 4 into square root of sin x. अब क्या रह गया? सिर्फ इस root x को integrate करना रह गया, which you can do easily. So it's going to be x square upon 2 plus 2x power 4 into square root of sin x, which is the correct answer. Okay, so क्या ख्याल आता है? Now you can probably understand why I had that reaction when I saw this question. You don't understand anything over here. Ouch. That's sad. So it's not that old, it's fairly recent. I wouldn't classify this as like a really old question. It's fairly recent. Yeah, this was definitely a tough one. I agree. Okay. So why not minus x square upon 2? Why would it be minus x square upon 2? Why would it be minus x square? Give me a reason why. Please ask Cambridge if this will come or not. Okay, sure. Anything else you want me to ask them? Should I ask them to make a separate paper for you? अरे भाई एक दफ़ा पूछ के रुक जाओ ना. Okay, you guys want to do another question? This is exactly what I was talking about. This is what I was talking about. Namaz break? So fine, let's take a break. Let's take a 10-minute break, shall we? Then we'll do this. How long will this stream last? I don't know, as long as it takes. A2 composite वालों को expected मिलेगा. Expected तो नहीं मिलेगा, assessed grade मिलेगा if and only if you haven't missed out both the components. Okay, so let's take a break, all right, and then we'll do this question. Okay, let's take a 10-minute break. And this is Asr break, okay? Not for those of you who haven't prayed Asr. Let's just call it a break, okay? Whatever you guys want to do. 6:26 हो रहा है ना? $6:40. ठीक है, fine. Then we'll have to break again at around 7:15 for Maghrib. Okay, if the stream lasts that long. Okay, so मिलते हैं around 10 minutes के बाद. ठीक है. Okay. Shall we start? So which of your streams should I watch for functions, cubic graphs and interpretation? I have a stream on cubic graphs. Yeah, I remember doing it last year. You should watch that. That's what I would recommend. Okay. You guys want to do this question? What do you say? We do this question and we call it a day. Okay. Now this is a very recent question. Okay. And it's a difficult one as well. Yes, Varisha, I do have a stream on permutation and combination. In fact, I've done lots of streams on permutations, combinations. Search it on my channel, you'll find it. Okay. I'll see if I have the time to do another stream on permutation and combination before the exam. But I don't know if I'll be able to do it. I'll try and do it tomorrow. Let's see. Okay. Or maybe I will do it tomorrow. Kal karte hain permutation combination. Okay. All right. Now, here's a question which, like I said, is fairly recent. Okay. And you're asked to do what? You're asked to find out the value of k, where k is what? Where basically area of A is to area of B is so and so, and one is the ratio of area is to ratio of area B is 1 is to k, and you're asked to find out the exact value of k. Okay. So सबसे पहले तो हम एक काम करते हैं. Let's find out the area of shaded region. Okay. Let's find out the area of shaded region. And this requires a decent amount of planning. Let's read the question first. Just realized I haven't done that. The diagram shows part of the line y equals to 1. So this is the line y equals to 1. Okay. And one completed curve of y equals to 1 plus cos x, where x is in radians. Okay. So immediately make sure that your calculator is in radian mode. All right. The line PQ is a tangent to the curve at P and Q. Okay. The line PQ is a tangent to the curve at P and Q. All right. Line QR is parallel to the y-axis. That means it's a vertical line. Area A is enclosed by the line y equals to 1 and the curve. Area B is enclosed by the line y equals to 1, the line PQ and the curve. Given that area A is to area B is 1 is to k, find the exact value of k. Okay. Now, let's see what we have to do in order to find out the area of shaded region. Now, before we do that, let's write down all the values. Okay. Now, since this is a graph of cos x plus 1, so normally the graph of cos x starts from 1, okay, and it reaches its minimum value when x is equal to pi, and then it goes back up, reaches its maximum value when it's equal to 2 pi, okay. If this is cos x plus 1, that means everything has been shifted 1 unit up, okay. So that means the coordinates of p will be, the y coordinate of p in fact will be equal to 2. So let me mark 2 over here, okay. And this is x coordinate 1. This over here is going to be pi. The x coordinate of r is going to be 2 pi. Okay, in fact, the coordinates of q will be 2 pi, comma 2. Okay, so make sure that you understand what I'm doing over here. And also, right, remember this, that a quarter cycle is completed at pi upon 2. Okay, and normally at pi upon 2, the graph of cos is equal to 0. But now at pi upon 2, the graph of cos is going to be equal to 1. Why? Because we are over here looking at the graph of not just cos x, we're looking at the graph of cos x plus 1. and then just like that, this point will be what? This point will be 3 upon 2 pi. Okay, so this is us just trying to get familiar with the question. So can you please see? Okay, I haven't had anyone complain about the mic volume. So I'll increase the sensitivity. Okay, there you go. I've increased it. Okay, now, is it fine now? Is it fine now? So should we know all these? Okay, you should know the basic shape of sine, cos, and tan. Okay, that goes without saying. You should know the basic shape of sine, cos, and tan. Okay. Okay, so let's start by finding out the area of B. All right. So how do we find out the area of B? Let's see, or maybe let's start with finding out the area of A. Okay, so that's what I'm going to do. I'm going to find out the area of A first. So in order to find out the area of A is what I'm now highlighting in green. Okay, A is what I'm now highlighting in green. Here's what I'm going to have to do. I'm going to have to first find out the area of rectangle. Okay, and from the area of rectangle, I will have to minus this region over here. I'll have to minus this region in red and minus this region in red, and that is how I will get the area of shaded region. Okay, so area of region A is going to be equal to this. It's going to be area of rectangle. Okay, so area, this is a 9-mark question, so remember, it's very important that you do your planning over here. And from the area of rectangle, I'm going to minus 2 times the area under the curve, which is 1 plus cos x. Now, you can either find out this area from pi upon 2 to pi, or you can find out the area from pi to 3 upon 2 pi. It makes no difference, but you have to multiply it by 2. Either way, you have to multiply it by 2. So pi upon 2 and pi. Okay, so that's going to give me the region A. Okay, so I'm not looking at the chat right now. I'm just focusing on the question. So whatever important questions that you guys have, just hold it. Okay, first I'll find out the area of region A, then I'll look at your questions. Okay, so let's start by calculating the area of rectangle. Now the area of rectangle has dimensions from pi upon 2 to 3 upon 2 pi. Okay, so you find out the difference to find out the length. So 3 upon 2 pi minus 1 upon 2 pi. So you don't need a calculator for this, but let's say you're using a calculator. So this is pi and this is 1. So the area of rectangle is equals to pi. So from pi, we now need to minus the area that we will find by integrating 1 plus cos x within the limits pi upon 2 and pi. So the integral of 1 will be x. The integral of cos x is going to be sin x. Why? Because remember, the differential of sine is cos. That means the integral of cos is going to be sine. Okay, within the limits pi and pi upon 2. And don't forget that this gets multiplied by 2 as well. Okay, so that part you can do at the very end. So first let's plug in pi. So pi plus sine pi. And then let's plug in pi upon 2. That means pi upon 2 plus sine pi upon 2. Okay, now let's see what do we get. So pi plus sine pi. Remember that your calculator should be in radian mode. So this gives pi minus pi upon 2 plus sine pi upon 2. Okay. Now since we have to keep it in terms of pi, we have to give the exact value. So just evaluate sine pi upon 2. Sine pi upon 2 is 90, so that's going to be equal to 1. So that means minus pi upon 2 plus 1. Okay. So let's see what do we get. Pi minus pi upon 2 is going to be pi upon 2 minus 1. Achha, like I said, wait a minute. Don't forget that you also have to multiply it by 2. So pi minus pi upon 2 minus 1. Okay, so all of this, remember, gets multiplied by 2 as well. Why multiplied by 2? Because if you're using the limits pi upon 2 to pi, you're only finding out half the region that you have to subtract. Okay, so let's do that. Pi minus pi upon 2 will be pi upon 2 minus 1, and then when you multiply it by 2, so you get pi minus 2. Okay, so this is what we get. Now let's find out the area of region A for which we decided that we are going to subtract rectangle minus the area under the curve. So a is equal to what? A is equals to pi minus 2. Okay, so this is what we get. A is equals to pi minus pi plus 2. So a is equals to 2. Okay, so this is just the area of region A. Now don't worry about what we're going to do next. Okay, don't worry about anything like that. Don't worry about what happens next. Just tell me if it's clear up until here. Sir, we cannot directly call the area from pi upon 2. No, because it's touching 0, so it's best that you don't. It's best that you break it up. ठीक है? वैसे आ तो जाएगा. You're very welcome to try it actually. You're very welcome to try it. Okay, that's a good question. Okay, now, so that's A. Now let's talk about B. Okay, now you have plenty of space that's given over here. Now I'm going to bring my attention towards B. Okay, so I'm going to clean this up, copy this, erase it, and let's find out area B. Okay, so in order to find out area B, we will have to notice that we already have the area of region A. Okay, that's equal to 2. Now in order to find out area of region B, we will first have to find out the area of the rectangle, and from it we'll have to subtract cos integrated within the limits 0 and pi. Okay, and we'll multiply it by 2 as well. Okay, because there are 2 regions, and then you also need to subtract this 2 over here. Okay, so that's what I'm going to do now. Let's start with the area of rectangle. Area of rectangle. Now this rectangle over here has dimensions 2 pi, because this is 2 pi by 2. Okay, so 2 pi by 2. So that means 2 into 2 pi, which is equal to what? Which is equal to 4 pi. Okay, now let's put this 4 pi on the side for now. We'll come back to it. Okay. Now, let's talk about the curve integrated within the limits 0 and pi. So 1 plus cos x, we are now going to integrate within the limits 0 and pi, and don't forget to multiply it by 2 as well. So we know already what the integral is. It's x plus sine x, okay, within the limits pi and 0. Okay, so pi plus sine pi with the upper limit plugged in, okay, minus the lower limit plugged in, which is 0 plus sine 0. Okay, so pi plus sine pi, I think we already worked that out, but let's do it again, is equal to pi. Okay, so pi minus 0, and then we multiply this by what? We multiply this by 2 as well. So this is equal to 2 pi. Okay, so 2 pi is, so basically this region is pi and this region is pi. Okay, now as I mentioned earlier, we also need to find out, we also need to subtract A. Okay, so I think we're almost there. So area of B, let me do this in green. Okay, so area of B is equals to area of rectangle, which turned out to be 4 pi, minus the area of these 2 regions, which turned out to be 2 pi, minus the area of region A, which is equal to 2. Okay, so 4 pi minus 2 pi can be further simplified and be written as 2 pi minus 2. So this turns out to be area of region B. Okay, so we're almost there. A is to B. A is to B is actually equal to 2 is to 2 pi minus 2. Now according to the question, we're supposed to bring it equal to 1 is to k. So how can I bring it equal to 1 is to k? I can divide both sides by 2, and if I divide both sides by 2, so it becomes 1 is to 2 pi upon 2 minus 2, 2 pi minus 2 upon 2 is equal to pi minus 1. So what is k equal to? K, as you know, is equal to pi minus 1. Now I don't have the answer to this, so although I remember this is the correct answer, but let me just double check. And let me know in the meantime, what are your thoughts about this? मजा आया आप लोगों को? Yeah, it's pi minus 1. ठीक है. Why not integrate from R to O? Okay, from R to O. Now the thing is, let me check. Because you have 0 in between, so I don't think that is gonna work. Let me check, because 0 usually, when you have 0 in between, you have to break it up. You're right, Wes, I could have done that. You're right, because it's not going below the x-axis. No, I could have done that. You're right. We could have directly integrated it from 0 to 2 pi. And here also, we could have directly integrated it from pi upon 2 to 3 upon 2 pi. Okay, so you're right. We could have done that. Okay. Okay, so basically here's A, and here's the area of A, and here's the area of B. So 2 into 2 pi minus 2. And according to the question, we were supposed to bring it like this. 1 is 2, k. So how do you turn this 2 into 1? You divide this by 2. Now in ratio, if you divide one value by 2, that means you divide the other value by 2 as well. So 2 upon 2 is 1, and 2 pi minus 2 upon 2 is going to be pi minus 1. So what's k equal to? K is equals to pi minus 1. So there you go. Yes, I have other. So look up, look at the live streams that I did last year. In it, I'm sure you'll find those hence find questions. Okay, किसने पूछा था ये? Khadija. Yeah, Khadija, look up the live streams that I did last year. I'm pretty sure I remember doing a hence find live stream last year. Okay, you'll find it inshallah. And Ryan, you're very welcome to try. Okay, let me know if it works. Okay, so let's stop here, and I'll do a live stream tomorrow inshallah. Tomorrow I'll try and stream permutations combination. Acha, permutation combination mein, what do you guys want me to do? Do you guys want me to do past papers, or do you guys want me to do concepts? Okay, so if the topics are the same, then I would suggest you watch videos from this year. But if, let's say, I did a stream of a topic which I haven't done this year, then of course I would suggest you watch it from last year. Okay, or you can watch both, honestly. Time, yeah, it's gonna be the same time, I think, 4 p.m. Let's do it at 4 p.m. Thank you, Intishar, means a lot. Let's keep it at 4 p.m. or I'll see if I can keep it early. Okay, I'll announce on my Instagram. Okay, I'll announce on my Instagram when I'm keeping it, either on my Instagram or on YouTube. Okay, alright, I'll try and do both inshallah. But remember, the concepts will be like a summary of the concepts, okay, not in detail. Alright. ठीक है, चलें. So I'll stop here. I'll see you guys tomorrow inshallah. Take care, keep studying. Make me proud, make your parents proud. Yeah, I have a lot of videos on differentiation. Okay, I have a playlist on differentiation, and then you can watch the stream where I did rates of change, and I also did maximum minimum value, stationary value. Okay, you can watch that. So cover ho jayega usse. Edexcel A-level mathematics. Okay, so I'm gonna have to look into like the fine content of Edexcel. So I can't make any videos now. Maybe from next year onwards. Next year onwards, I have a lot of students requesting to make Edexcel content, Edexcel and GCSE. So maybe from next year onwards, I can make a separate channel for that. This year, I'm afraid I won't be able to do that. Okay. Anyway, so that's it. Take care, everyone. I'll attach this file, upload this file, the partially solved version, on Dropbox. Okay, and then you guys can download it from there.